Friends, in this video let us see the different types of clipper and clamper circuits. Clipper circuits. A clipper is a circuit which clips off certain portion of the output waveform. Clipper circuit can be categorized into four types. First one is positive clipper. A positive clipper is a circuit which clips off positive portion of output waveform. Second one is negative clipper. A negative clipper clips off negative portion of output waveform. Then double-ended symmetrical clipper. So in this double-ended symmetrical clipper, both positive and negative cycles are clipped at equal levels. Then fourth one is the double-ended asymmetrical clipper, wherein positive and negative cycles of the output waveform are clipped at different levels. So now let us see with respect to schematic diagram how these clippers will clip off certain waveform of the certain portion of the output waveform. So positive clipper. So positive clipper is as shown in the schematic diagram here. So basically a clipper consists of a diode and a reference voltage VR. In positive clipper, the direction of the diode and VR are as shown in the figure. So when input signal is applied to this clipper circuit, so input signal consists of positive half cycle and negative half cycle equally 5 volt above and 5 volt below in this example. So peak to peak value of 10 volt. Okay, when this positive half cycle and negative half cycle are applied to this circuit, a combination of diode and VR, the output voltage will be nothing but the voltage available across this end and this end. So that is, as a design wise, we can see that output waveform or the positive side, for the positive half cycle of the input, the diode is conducting and there will be a drop of Vd across the diode and VR value will be in series with that Vd. So totally the output voltage will be equal to plus Vd plus VR. So for positive half cycle we indicate output as V0 max. So V0 max will be equal to Vd plus VR, so which is this portion. So now suppose the Vd value is 0 and VR value is 0, so the output voltage will become 0 for the positive half cycle, means entire positive half cycle will be clipped off. But practically we designed the certain portion of the positive half cycle to be clipped off. So there will be minimum of Vd, that is 0.7 volt already available. Depending upon our requirement, we add additional voltage of VR value. Suppose if you want the clipping level at 2 volt, so clipping level at 2 volt, so V0 max value is 2 volt, so Vd is 0.7 volt, VR will be equal to 2 minus 0.7 will be equal to 1.3 volt. Likewise, if we want 3 volt V0 max value as 3 volt, at that time 3 minus 0.7 will be 2.3 volt, means we need to add that additional 2.3 volt in order to achieve the 3 volt level of the clipping. So during negative half cycle the diode is reverse biased, therefore the entire connection is open circuited, hence the output voltage will be exactly equal to the negative half cycle of the input. Therefore for the negative half cycle V0 minimum we indicate, so that will be equal to minus Vm, or in this case you can see minus 5 volt. So input level are plus 5 volt and minus 5 volt. So for the positive clipper, certain portion of the positive half cycle is clipped off, and that value depends upon the required level. So it may be 3 volt, 2 volt, 4 volt. Below the maximum value of 5 volt, any value can be given right from 0.7 to 4.9 volt or so. Okay, so this is how the positive clipper works. It clips off certain portion of the positive waveform and passes entire negative half cycle to the output. Now negative clipper is achieved just by reversing the direction of the diode and the VR value. So same operation can be obtained for the negative half cycle, and positive half cycle can be passed as it is, so which is shown in this diagram here. So in this diagram the diode is reversed and VR is also reversed. So in this case, So we not during positive half cycle, so the diode will be reverse biased, therefore the circuit is open and an output will be equal to the applied input. So V naught max will be equal to Vm, or it is equal to 5 volt in this case. And during negative half cycle the diode is conducting, therefore the voltage available will be equal to the diode drop and the value of Vr. Since the sign convention is opposite, output terminal positive here and negative here, but inside the circuit total negative is this side and positive is this side. Therefore for the negative cycle, if I write the expression, it will be V naught minimum representation wise, that will be equal to, so this side minus Vd and minus Vr. So it is minus Vd minus Vr. So depending upon our requirement, we will be able to get the value of Vr here. Suppose if you want 3 volt as the minimum level, at that time the diode drop will be equal to minus 0.7 volt. So Vr will be equal to V naught plus V naught minimum plus Vd. So that time, for example, it is 3, so minus, this will be equal to 0.7 minus Vr. So Vr will be equal to, so taking Vr to this side and 3 to this side, so we will be able to get so V naught minimum, if you want at minus 3 volt, so that time, so Vr can be obtained by taking Vr to this side and minus 3 to this side. So that time it will become 3 minus 0.7 equal to 2.3 volt with the shown direction. So Vr value should be kept at 2.3 volt in order to obtain the clipping level at the negative side as minus 3 volt. Positive side it will be equal to positive input value, negative side it will be clipped at the designed V naught minimum value. Now in case of double-ended clipper, both positive clipper and negative clipper are combined together in order to clip off positive half cycle as well as negative half cycle at the desired level. Now due to the clipping levels, so there may be two possibilities. One is symmetrical, another one is asymmetrical. So in case of double-ended symmetrical clipper, both the positive half cycle and negative half cycle are clipped at equal levels. So here you can see the diagram of the double-ended symmetrical clipper. So positive clipper is taken, negative clipper is taken, then they are connected together and input is applied to this combination. So during positive half cycle, positive clipper will act and it will clip off positive half cycle to the desired level. During negative half cycle, positive clipper is open, negative clipper will act and it will clip off at the desired level. Therefore the design expression for the double-ended clipper can be written as V naught max equal to, so only positive clipper will be acting at that time, so it is Vd plus Vr. And for the negative half cycle, the negative output or indicated as V naught minimum will be equal to minus Vd minus Vr. So for positive 3 volt and negative 3 volt, if you calculate the value of Vr, it will be equal to, for V naught max equal to 3, so it will be 0.7 plus Vr. So therefore Vr will be equal to 3 minus 0.7, 2.3 volt. And for negative side, equal value negative, so minus 0.7 minus Vr. Vr will be equal to 2.3 volt. So Vr1 and Vr2 value should be same in order to obtain clipping level, clipping values at equal levels on positive and negative side. Now if the values are unequal, at that time the clipper is called as a symmetrical clipper. In example here, so again the connection was positive clipper and negative clipper as it is, they are connected, but Vr1 and Vr2 will be different. Suppose in this case it is 4 volt, so at that time Vr will be equal to 4 minus 0.7 will be equal to 3.3. If V naught max is 4. Okay, and if v naught minimum is say minus 3, so already we have seen for minus 3 VR value will be equal to 2.3 volt with the shown direction. Okay, so now in asymmetrical type of clipper there is a possibility that the negative half cycle can be clipped on the negative side, as well as we can we can take the clipping level above the reference line also. That means some portion of the positive half cycle from the negative side can be clipped off, that is as shown in the diagram waveform here. So some portion towards positive side is also clipped. Now this can be achieved by reversing the direction of VR. Okay, so as shown in the circuit here. Okay, so usually for the negative clipper, the VR value is indicated, VR direction is indicated with negative here and positive here. But in case of asymmetrical, that too with positive clipping on the negative side, so VR should be reversed. That is because we want say V naught max equal to 4. So as we have seen here, VR will be equal to 3.3 volt, no problem with that. Now V naught minimum, so V naught minimum, if you see, V naught minimum is, instead of negative value it is plus 2 volt. So therefore when you substitute that V naught minimum equal to 2 volt, VD is minus 0.7 and minus VR. So when you try to calculate that VR value, so at that time it will become minus 2.7 volt. So now negative voltage is not possible. So in order to give the negative value of 2.7 volt, we have to interchange the plus and minus terminals as available in this connection, like this, in order to achieve that negative side value of the VR, in order to go to the clipping level of plus 2 volt. Okay, so this is how we can design the different clipper circuits as per our requirement. Positive, this is the direction, anode, cathode and VR, plus minus, negative, cathode, anode and negative, plus negative, positive VR. Then combining both, symmetrical VR1 VR2 same, asymmetrical VR1 VR2 are different, as well as in asymmetrical for the positive side VR2 should be reversed. Okay.